It's time to graph some more rational equations. I know you guys love them. I know you guys love them. Jenny, do you love them? Jenny's here. She's going to help out. She's got her calculator just in case. But you know what? This is going to be a non-calc problem, so let's get to it. First things first, let's go ahead and factor. Doesn't look like our denominator is factorable, but our numerator most certainly is. Maybe. We'll see. All right. It's a lead coefficient, though, so well, how are we going to go about factoring with a lead coefficient? Most of us like to use what's called rainbow method. So we have 3x squared minus 11x plus 6. I need to multiply to 18 and add a negative 11. Well, that would be negative 9 and negative 2. Multiplies to positive 18, adds to negative 11. Next, I'll go ahead and break apart that negative 11x into those two numbers, and then I'm going to group the first two and the last two. I'm going to pull out a GCF. So I'll have 3x, and then I'll have x minus 3 left in there, and then I'll take out a negative 2, and I'll have x minus 3 left in that one. All right, so now my two factors are going to be 3x minus 2 and x minus 3. Lovely. Leading coefficient factoring is never going away, so you just kind of have to learn it, all right? All right, wonderful children. All right, let's do that. So now we're going to have 3x minus 2, and we'll have x minus 3 in my numerator. My denominator is x minus 2. Now, let's start going with our domain. Well, my domain, we look at our denominator. Whatever's going to make that 0, that's our domain restriction. So that's going to be x cannot equal positive 2. No other restrictions there for the domain. Holes. Did I have anything cancel? Nope. No holes. Okay. How about vertical asymptote? Do we have anything left in our denominator? Yes. So that'd be x equals positive 2 for my equation of that vertical asymptote. Next up, horizontal asymptote. Well, now we're looking at our degree. So our degree in the numerator is 2, and our degree in the denominator is 1. I always just look back at the original for that, because sometimes when it gets into factored form, it's not as quick and easy to see. Well, if I have a larger degree in the numerator, that means that I'm going to have an oblique asymptote, so there's going to be no horizontal asymptote. We're actually going to have a slant asymptote or oblique asymptote. So how do we go about finding the equation of this slant asymptote? Jenny's wondering. I don't know if you can hear her whining, but she's wondering. So let's go to it. I like to use the method of long division, although in this particular one, you could use synthetic division if you wanted, but long division is the more universal method, so I'm going to set that up. So first things first here, when we talk about long division, I want to know x times what would give me the 3x squared, or you can think of it as 3x squared divided by x, and what is that? Either way you want to slice it, your call. I'm going to go with the x times what gives me 3x squared. That's going to be 3x, and I'll jot that down up top there. Now I'm going to multiply that 3x to both my x and my negative 2 to get me 3x squared minus 6x. Now what I have to do is I have to subtract those with the ones above them. So subtraction, this becomes addition. These are going to cancel. They always will if you did it correctly. And then I'm going to have negative 5x. Drop my 6. And now I'm going to say, okay, well, x times what gives me negative 5x? That's going to be negative 5. Now, the great thing about finding our slant asymptotes is I am done. Okay? Once I have the equation of a line in y equals mx plus b slope-intercept form, I'm done. So that means my slant asymptote here is 3x minus 5. Y equals 3x minus 5. It's going to be an equation of a line. Kind of steep. All right? Lovely. Fantastic and wonderful. Next up, we have to get our x-intercept, or possibly intercepts, and our y-intercept. Let's see what we've got. Well, for my x-intercepts, I need to set y equal to 0 and solve for x. So that means that I'm going to have some kind of an ordered pair, or maybe two ordered pairs, where I have something comma 0. Let's see here. So if I'm setting y equal to 0, that means my equation is going to equal 0. How am I going to get my equation to equal 0? Would I need 0 as a value in my numerator or in my denominator? Well, I can't have it in my denominator because then it's undefined. So I'm really just looking at getting my numerator, which is already in factored form here, to be 0. All right. So if I can get one of those two to be 0, then it's going to be 0 in the numerator divided by negative 2, right? Or sorry, divided by something, not necessarily negative 2. So that would give me 0. 0 divided by anything is 0, as long as we're not dividing by 0. Keep that in mind. All right. So I'm going to set each one of these factors equal to 0, and I'll solve. So I'm going to get x equals positive 2/3, and I'll get x equals 3. So we do actually have two x-intercepts here, one of them being 2/3, comma 0, and the other one is going to be 3, comma 0. Awesome. And then lastly, we got to get our y-intercept here. How do I get my y-intercept? Well, I would set x equal to 0. So if x is 0, comma, something, well, how do we find that something? I'll substitute 0 in. I find this easiest to do in the original equation because what's going to happen is this becomes 0, that becomes 0, this becomes 0, and I'm left with positive 6 divided by negative 2, which is negative 3. We have everything. Let's start graphing it. All right, so I decided to change my vertical asymptote equation to green, and I'll make the marker a little bit thicker so we can see it here on the graph. I like that. There we go. Put some arrows on it. That's my x equals 2. Next up is my oblique asymptote. I'm going to get myself out of the way here. Whee! All right, and we're going to go with that in the pink marker. Let's make it a little bit thicker here. Now, I'm going to start down at, it looks like negative 5. So 1, 2, 3, 4, 5. For those of us that forgot how to graph an equation of a line, a basic equation, right? And then we're going to go up 3 and over 1. That's my slope, 3 over 1. So now I can just go ahead and connect these two dots with a straight edge. Hopefully you're strapped up with a straight edge. I'm always strapped up with a straight edge. You know what I'm saying? All right, there we go. Lovely, lovely, lovely. All right. Beautiful stuff. Next up, let's go ahead and plot our x-intercepts. Okay, so my x-intercepts are 2/3, comma 0, so I'm going to be chilling right around here. And then I've got 3, 0, which will be right at this spot here. And then my y-intercept looks like negative 3. So 0, negative 3 is right there. And now I can come through with the graph of this line, which I'll do in light blue here. And let's beef up that marker. So I'm going to have something that looks like this, that follows that oblique asymptote and goes through those and then follows on up to my vertical asymptote. And the other one will be shaped again by both asymptotes. Beautiful stuff. We're not crossing those. It can cross an oblique or a horizontal asymptote. This one does not, but it will never cross that vertical asymptote. So there we go. We got everything down, all set. That was awesome. America, freedom, rock and roll, Costco, Riverdog Jenny on the gram, and of course, YORO when needed, but this was a non-calc problem. See ya.